Hi everyone, we are a software development team named Nhigiri. Today we are going to present new software requirement specification for team formation system. The purpose of this team formation system is to assemble capstone project team consisting of 4 members in the most effective and successful way possible. This system is designed to address 2 main problems of previous system, which are insufficient number of members for external project and poor match between team members. There are 3 intended users for this system: client, lecturer, and student. Client will be able to provide their project ID and details and manage them using web application. Student will submit their profile to provide their capability, previous experience, and preference, and submit a request for swapping members. The lecturer will be able to review the project and modify the project constraints if necessary by discussing with the client, and accept the request and forward it to the system for processing. The next slides will be presented by my other team members, Ni.
So now I will explain the data flow diagrams and give you an overview of the system UI and UX. And first use case where the students submit their profile onto the system. First, the student has to verify their authentication by giving the information of their identification, and they will be compared with the one stored in the student database. And they will give the student access if all of those information are valid. It's valid. And to add the profile, the student has to provide this information, and it will validate the input and store those data into the profile database. And later on, if the student wants to update their profile, they will send a request to the system, and the system will give them the old data, and they will update those data and commit those change and send it to the profile database. This is the data flow for adding a new project onto the system by the project manager, which is the client. And the process is actually quite the same with the submit a profile in the previous slide. So we can move on to when the project manager or the lecturer want to update the information, the data of the project. They will send a request to the system, and the system will send back the project data, the old data, and they will update the data and replace the old data in the database and store it again, and create a new notification about the update and store it in the notification database, and those notifications will be sent to the other parties. And if the lecturer or the client want to add a new project constraint, they will send a request to the system, and then they will add the constraint. They will add a constraint, and based on the project ID that they chose, it will update that constraint into that project and then store it again in the project database. And if they wish to remove a constraint, then the system will, based on the ID of that constraint, and delete it in the database. And this is the data flow for change the constraint weight use case, and it's the same. It's very similar with the update the project from the previous slide. The process is the same. They will choose the project. They will choose the constraint they want to update, and update the new, give them a new weight, and store it again, and it will notify the other parties. And when the student want to making swapping requests to change the team, they will first the system will provide them with the information about their current team and the members on that team, and they will submit a new swapping request, and that request will and the system will check the request status and notify the student, and then the student will be given a team list and the member list of each team, and they will from the team database, and they will choose the student they want to replace their position, swap the teams with, and make the request, and that request will contain the user ID and the destination user ID and store it in the request management database. And to verify that swapping request, the lecturer will set a swapping value, and that swapping value will be stored also in the request management database. And so the lecturer can view, send a request to view the pending request list, and they will approve that request if it meet all of the requirements, and then send that request status to that to the request management database, and the team list and the member list will be updated in the team database. And these are the overview of the UI and UX of the system.
Okay, so I'll talk about the activity diagram of our system. Here we have three streamlines representing the three actors of the system, which is the client, the lecturer, and the student. Firstly, the initial note is that the client will create a project. After that, the lecturer has the option to review the project. And if he found a problem, he will proceed to the next step. But if there is a problem with the project, then the client will need to edit the project, and then we will branch back to the review project by the lecturer. Here, the lecturer, there is a fork, which means that the action here can be completed concurrently, which is adding constraint to the project and then setting the constraint width. After that, the lecturer will publish the project, and then the student, after seeing the project's details, they will submit the profiles. In the profile, they will include their preference, their skills. After that, the system will allocate the student into teams. If the students are happy with the current teams, then it will go to the flow stop node, which means that the student has allocated into the team successfully. If the student have problem with the teams, they can submit a swapping request, and this will go to the lecturer, in which the lecturer can either choose to dismiss the request or approve the request. Either ways, both actions will merge back into this activity, which means that the student will be either allocated into the new teams or they kept the current teams, and it go back to the activity subnode. Okay, so I'll talk about the class diagram of our system. The class diagram represents the static structure and behavior of the proposed system. It will consist of classes, its property, methods, as well as the association between two classes. Firstly, I will only mention about the key classes of our class diagram. Firstly, we have the abstract class users, which represent the users of our system. Every user will have a string ID, a password, and they have a method such as login and logout, and these properties and methods I will set to private because they consider private information of the users. And the user class can be instantiated by the three children classes such as the client class, the lecturer class, and the student class. And each of the classes we have its own property and implement its own methods based on its function. For a client class, the client class can create a new project, can edit a project, can add constraint to the project, as well as delete a project. For the lecturer class, it is able to edit a project, add the constraint to the project, delete a project, as well as change the swapping value of the teams, change the constraint width, as well as approve or dismiss the swapping request submitted by the student. The student will have its own properties, such as whether the student is in a team or not, and a student will have a student profile. Since the student profile is heavily dependent on the student, the relationship between the student and the student profile class will be a composition. A student will be able to submit a profile, submit a swapping request, delete a profile, as well as delete his or her own swapping request. Next, we'll talk about the project classes. Every project will have an ID, a name, a description. A project is created by one client, and a project is also have one lecturer at a time. And lastly is the project team classes. The project team classes is created after the system has allocated a student into a teams. A project team will have one project owner, which is the client, one project manager, which is the lecturer, and 4 students. And a student can only belong to one project team at a time. A project also consists of an array of constraints. A constraint can either be a hard constraint or a soft constraint. For a soft constraint, it will have its own property, which is the constraint weight. And the value of the constraint weight can be enumerated by the constraint weight class. And it can take 4 values from 1, 2, 3, and 4.
The object diagram is based as an instance of the class diagram. Here too, we divide the objects into 3 groups. First are the user groups, which are the clients, the good company, the lecturer, the John Doe, and the student, Jane Smith. Second group is the project group, which contains the project and its hard constraint and soft constraint. And the project here is the project e-commerce. The name is the project e-commerce, and it has a hard constraint of finished by Jan 2020, and a soft constraint of simple design. And the third group is the project team and the supporting objects from the supporting classes. Project team is project team 3 is the project where the Jane Smith belongs to. But project team 3 also is also in charge of the project e-commerce, and the other supporting objects contains the swapping request from Jane Smith, Jane Smith profile, student profile, and the email notification to the respective users. And the project team should have a connection to its project manager, John Doe, the lecturer, and the team members, the student, Jane Smith, and the client, the good company. Regarding the constraints of the project, the finish by 2020 hard constraints is a deadline for the project, which is implemented as a hard constraint, and the project must be finished by January 2020. And the soft constraints is simple design. The constraint description is implements a simple design to the user interface for the project. The project description here is creates an e-commerce website, and so these 3 are the users, this is the project, and this is the project team. Regarding the performance of our system, the response time should be interactive and have as little delay as possible. Each delay in window popping up form or error message or fetching the database should be less and no more than 2 seconds. And the connection for a successful connection between servers, response time should be more or less than 20 seconds. And regarding the availability, the system should be available 95% of the time in a month, and the 5% should be used to maintain the system server and fix all the bugs, etc. And if there is a internet disruption from the user side or server side, then server should resend the data for verification. For security, because hacking into accounts is a very serious security concern, the system should implement proper login and register mechanisms and using strict identity validation. And for the data transmission, the data should be securely transmitted from servers to the database or to the users. And for maintainability, a system bug when found should be fixed in about 24 hours or less, and that is expected of the performance of the system.
Project timeline is planned based on semester 1 2020, 2 days on gathering requirement, 3 days for analyzing conform requirement, 16 days for design server and database, 7 days for API test and feedback, 7 days for research and settle front-end design plan, and roughly 2 weeks for design UI, and then 3 days for internal system test, 5 days for user acceptance test, and 10 days for performance optimization and final UI improvement, And finally, project delivery on 22nd of May. As it was outlined on the previous slides, there are 3 testing plans. Firstly, API test. The purpose of API test is to evaluate whether the application meets expectation for functionality, performance, and security. This test will be conducted by backend developer using Postman and local web server. Secondly, system test. System test is to evaluate the software's compliance after integrating backend with frontend. This test will be undertaken in cloud environment to mock real-world application. Tester will try to perform all functionality of application to observe if any component doesn't behave as it is expected. Lastly, user acceptance test. User acceptance test will be conducted at the last phase of development to give test participant opportunity to interact with software and for software team to receive feedback from them. And the test participant will be required to complete each task following task instruction on the task script and find out systemic flow. It was the end of the presentation. Thank you for watching.